This video will show the end of section 5, part A. So we're still talking about creating confidence intervals, and I had added, this is specifically for a proportion. Okay, so we had talked about the steps in which we calculate the confidence interval, and so far we had gone over calculating the confidence interval at a 95% confidence level. And so recall then, let me go back one slide here, that the equation that we use for the confidence interval is the point estimate, so that's our proportion, our sample proportion, plus and minus 1.96 times the standard error. Okay, so 1.96, the reason we use that, it's always used for a 95% confidence interval because that goes back to our distribution in the empirical rule, with 95% of observations being between approximately 2 standard deviations from the mean. Specifically, it's 1.96 standard deviations from the mean. So that's why we're using that. So it's the point estimate and then plus and minus the 1.96 times the standard error. So the standard error formula listed there is equal to, and we use the p hat, which is the sample proportion, in place of the population proportion because the population proportion is unknown. So ultimately that makes this formula here down at the bottom. Let me try and get my mouse to show up. The p hat times 1 minus p hat divided by n, and then taking the square root of that. So here's our final formula then for calculating a 95% confidence interval. So the point estimate plus and minus 1.96 times the standard error. So the last thing that we had gone over was calculating this example. So I added a little bit more details on this slide so that shows you every step that we were going through in reducing the standard error formula. So again, we have 1,000 adults in our sample, and of that, 88.7% said that they support expanding the use of solar power. So to change or transform that 88.7% into a proportion, so we can either multiply that value by 100, or we can move the decimal place over to the left 2. So when we do that, and moving it over 2, that gives us 0.887. So the proportion that supports the use of solar power in that sample is 0.887. So we're calculating a 95% confidence interval for this particular scenario. So we have our formula listed here, the point estimate, which again is the sample proportion, so that's p hat, plus and minus 1.96 times our standard error formula. So remember, the 1.96 is being used because we're calculating a 95% confidence interval. So 1.96 is always used for a 95% confidence interval. So we plugged in our information. The point estimate is 0.887, that's p hat, plus and minus 1.96 times our standard error. So we've plugged in a few values. The p hat is, we're plugging in our point estimate, which is the sample proportion, so that's 0.887. And then we have 1 minus p hat, so it's 1 minus, again, p hat is the sample proportion, 0.887, divided by n. So n is our sample size, and that was given up here. So we know that there was a sample of 1,000 people. So in these, I've just made it more detailed to show you the reduction. So we first, always following our order of operations, 1 minus p hat, so that's reduced here. So 1 minus 0.887 is equal to 0.113. Our next step in the order of operations is to multiply the numerator there. So 0.887 times 0.113 gets us this value over here, 0.100231. So then the next step in the order of operations then is to do the division within that. So 0.10023 divided by 1,000 gives us this value down here, 0.0001. And then we take the square root of that, which gives us the value of 0.010, okay? So all of these steps are just showing how we reduced the standard error and we solved for the standard error. So ultimately our standard error is 0.010. So then we have this particular formula, and this is our formula now that we are going to use to solve for the confidence interval. So the first thing that we do, again, following the order of operations, is to do our multiplication. So 1.96 times 0.010. So that section right there, 1.96 times 0.010, gives us this value here, 0.0196, okay? So once we have that particular value, then this is our last step that we have to do to create the confidence interval. So we first do 0.887 plus 0.0196. That gives us the upper end of our confidence interval, so the higher value, okay? After we do that, well, and I'll show you, so the result of that, 0.887 plus 0.0196 gives us a 0.9066. That's the upper end of our confidence interval. So after we do that, then we have to subtract it. So we do 0.887 minus 0.0196, and that gives us this value here, 0.8674. That's the lower end of the confidence interval. So you'll notice on the homework that the steps that you'll be taking, you'll be calculating a 95% confidence interval, and in the questions it asks you to the answers to put in is, in one question you put in the upper end of the confidence interval, and then in the next answer you would put in the lower end. So the upper end, and I'll try and write this out here, the upper end is always found with the addition in that problem, right? Then the lower end is always found with the subtraction in that problem, okay? So you have 0.887 plus 0.0196, that was our upper end of the confidence interval, and then 0.887 minus 0.0196, that gives us the lower end of our confidence interval. So these two values here, the 0.8674 and the 0.9066, that is our confidence interval. So the confidence interval is that range. So how do we actually interpret that particular confidence interval? Because this is a 95% confidence interval, we are 95% confident that the actual proportion in the population, so our population of American adults, who actually support expanding solar power, is somewhere between this range of proportion. So it would be somewhere in there between 0.8674 and 0.9066. So instead of presenting it as proportions, the interpretation of it might be a little bit clearer if we change it back to percent. So this is then transformed. So again, you can multiply that by 100, or you move your decimal place over 2 spots, and we have 86.7, so that's listed there. I should have just put the arrow over there. And then our upper end of the confidence interval, so 90, we're moving the decimal place over 2, 90.66, right? So that's over here. So that tells us, and that's been rounded, I should point that out. So, and I guess I will write it out. So 86.74, right? That one decimal, rounding that to one decimal, since that 4 is not 5 or above, you don't change that 7, so that's why it's 86.7. And then the 90.66, rounding that to only one decimal, because that 6 is 5 or above, that's going to bump the 6 in front of it up. So instead of that being a 6, that'll be changed to a 7, right? So that's why it's 90.7. We've rounded that. So in any case, so interpreting this this confidence interval, we are 95% confident that the true or real proportion of adults who support the expansion of solar power is somewhere between 86.7% and 90.7%. Okay, so that's an example of a 95% confidence interval. So the next slide that we'll go over here is another example. So in this case, we have a sample of 1,042 adults in New York. And that particular sample, some kind of survey reveals that 82% of that sample supports a mandatory 21-day quarantine for anyone who's come in contact with Ebola. This, I believe, is a real survey. This information's from your book. So I believe it was conducted between October 26th and 28th in 2014. And the circumstances were that a doctor had been treating Ebola patients in Guinea and had gone to the hospital with a slight fever and was eventually diagnosed with Ebola. And so then they had implemented this poll to see what the adults in the area thought about mandating quarantines for anyone who's been in contact with someone else who had Ebola. So in that questionnaire, 82% of those respondents said that yes, they do support the quarantine for the circumstance. So the question then would be, you need to compute and interpret a 95% confidence interval for the population proportion. So we want to find what range does the population proportion truly fall under. So we have, again, our equation, the point estimate, plus or minus 1.96 times the standard error. So our point estimate is 0.82 plus or minus 1.96. It's always 1.96 because that's a 95% confidence interval that we're using. And then the standard error here, we have p hat. Again, that's our sample proportion. So 82% is equivalent to a proportion of 0.82. So we have 0.82 there. And then we have 1 minus p hat. So p hat again is 0.82. And then our sample size n, we obtain that in the question. There's 1,042 adults. So that's what goes on the denominator. So just like what we did with the last slide, the steps that we have to do, we are first going to solve for the standard error. So we always do our subtraction inside the parentheses first. So 1 minus 0.82, that gives us this value over here, 0.18. All this other stuff in the equation is staying the same. So we're not dealing with anything else in the equation until we finish solving for our standard error. So after we've done 1 minus p hat, then we take and we multiply the remaining information that's on our numerator. So we have 0.82 times 0.18. So when these two values are next to each other in parentheses, that means multiplication. So 0.82 times 0.18, that gives us a value of 0.1476. Now the next step in following the order of operations is to actually do the division here. So 0.1476 divided by 1,042. So putting that in your calculator, that gives us a value of 0.000142. After we've done that, we're now at the very last step of our equation for the standard error. We just have to take the square root of that. So taking the square root of 0.000142 gives us this value here, 0.012. So now we're at this step in the equation here, wherein following the order of operations, now please excuse my dear Aunt Sally, we have to do our multiplication. So we need to multiply 1.96 times 0.012. 1.96 times 0.012 gives us 0.024. Okay, so that's the steps that we take to get to the end of our equation here. So this is our very last step to get the confidence interval. So if we do the upper end of our confidence interval, that's referring to when we make the addition. So 0.82 plus 0.024. That's our upper end of our confidence interval. So then the lower end of the confidence interval is the subtraction, 0.82 minus 0.024. So 0.82 minus 0.024 is the lower end of the confidence interval. So those two values that are obtained there, that's our confidence interval in the form of proportions. Changing that confidence interval to percentages, we would have 79.6% and then 84.4%. Okay? So, how we actually interpret that confidence interval for this sample proportion is that we are 95% confident that the true or real proportion of people who happen to be New York, adults who live in New York, that support or who support a mandatory 21-day quarantine for anyone who's come in contact with someone who has Ebola, is somewhere within this range, right? So somewhere between 79.6% and 84.4%. So we're 95% confident that the actual real number or percent of adults who agree with that is somewhere in there. So our sample suggests that it's 82%, but instead of just providing that 1 point estimate as our conclusion, we can present this confidence interval and say that we're 95% confident that the actual value of the entire population is somewhere between 79.6% and 84.4%. So that's a 95% confidence interval. So anytime that you do a 95% confidence interval, this is the formula that you'll use here, okay? So the next example that we're going to go over is a 99% confidence interval. The only thing that differs in a 99% confidence interval or any confidence interval is this value. That's the only value that's going to change. Okay, so I'll show you that here. So for a 99% confidence interval, instead of using the value of 1.96, which corresponds to approximately, let me just draw this out. So remember, in our empirical rule, 1 standard deviation below and 1 standard deviation above the mean contains 64% of our data, or excuse me, 68% of our data. 2 standard deviations below and 2 standard deviations above the mean contain about 95% of our data. So that 2 standard deviations, what we've just learned, that it's actually, instead of 2 standard deviations, it's exactly 1.96 standard deviations. And then now what we're talking about here, 99% of our data falls about 3 standard deviations below and 3 standard deviations above the mean. But instead of what we've gone over before, this approximately 3 standard deviations, it's exactly 2.58 standard deviation. So this is the more accurate value. Is that 99% of our data falls exactly 2.5 standard deviations below the mean and 2.5 standard deviations above the mean. Okay, so that's what's included here, 99% of our data. So remember, that's the empirical rule. Now we're just being more specific with it. So instead of 1 standard deviation, 2 standard deviations, and 3 standard deviations, this is much more specific. So instead of the 2 standard deviations, we're talking about 1.96. Instead of 3 standard deviations, it's exactly 2.58 standard deviations. So in with regard to creating a confidence interval then, for a 99% confidence interval, we utilize that 2.58 value to create a confidence interval that's exactly 2.58 standard errors from the sample proportion that we obtain. And that then ensures that we're 99% confident that our interval that we create, the confidence interval that we create, contains the true population proportion, which is P, right? So again, with a 95% confidence interval, a 95% would mean that, say we took, 1,000 samples and we built a 95% confidence interval from every single one of those samples, that about 95% of those intervals would actually contain the true population parameter, right? So same thing with a 99% confidence interval, that if we create a 99% confidence interval off of a sample proportion, say we do that 1,000 times, the sample proportion, we've obtained 1,000 times. We then create a 99% confidence interval for each one of those 1,000 sample statistics that we obtain, those proportions, that of all of those 1,000 confidence intervals that we created, about 99% of those intervals would actually contain the true population parameter. Okay, so that then is kind of like the underlying meaning behind these confidence intervals and the difference in the 99% or 95%. So our next bit of information here is just to show how do we actually calculate the 99% confidence interval. This is exactly the same as how we calculate the 95% confidence interval, except the only difference, instead of using a value of 1.96, now we're using a value of 2.58. So in the equation, it's still the same thing. The point estimate is the sample proportion, plus and minus 2.58 times the standard error, and then 2.58, then we would take the point estimate minus 2.58 times the standard error, okay? So again, just like before, you can think of these kind of as two different equations, right? So we're doing one equation where it's the point estimate plus 2.58 times the standard error, and then we're doing another equation where it's the point estimate minus 2.58 times the standard error, okay? And then the standard error still stays the same. So by all technicalities, our standard error is the square root of the population proportion times 1 minus the population proportion divided by n. But again, we don't have the population proportion, right? So we're using our sample proportion, or p hat, in place of that equation. And so in doing so, that changes the standard error equation to be p hat times 1 minus p hat divided by n, and then taking the square root of that. So that's still all the same. So the only difference between a confidence interval for 95% and 99% is that for a 95% confidence interval, 95% confidence interval, we'd be using a value of 1.96 here, right? Because we have our 2.58 here, we know that it's a 99% confidence interval. So this is our equation now that we'll use to create a 99% confidence interval. So our next slide is an example of all of the steps of how to do that. So remember, in the first example that I did with a 95% confidence interval was the same information. A sample of 1,000 adults. Of those 1,000 people who responded, 88.7% said they support the use of solar power. The only difference between the calculating a 95% confidence example, number one, and this one is that instead of a 95%, we're now calculating a 99% confidence interval. Okay? So we're going to write out our equation here. our confidence interval equation for our 99% confidence interval is the point estimate plus 2.58 times the standard error. And then the second portion of that would be the point estimate minus 2.58 times the standard error. Okay? So this is showing all of our steps then to create and actually solve for our confidence interval. All right. So the very first step that we have is filling in those values. So our point estimate is 0.887. We're leaving our value of 2.58. And then we're filling in the standard error here. So p hat is 0.887. Then we have 1 minus p hat. So 1 minus 0.887 divided by n. So our sample size is 1,000 based on what was given to us in the information in the question. So now these remaining bits of information is just showing you how we are reducing or solving for the standard error. So this is the same numbers that were on the slides a couple slides ago, right? So the very first step that we do in following the order of operations is to solve 1 minus 0.887. That gives us 0.113. Again, everything else in the equation stays the same. We're only focusing on solving the standard error right now. Once we do that, the next step is to multiply the value in our numerator. So 0.887 times 0.113. So doing that, 0.887 times 0.113 gives us a value of 0.100231. The next step would be to take 0.100231 divided by 1,000. Let me erase some things on the slide. Doing that division, that gives us this value here, the 0.0001. Everything else in the equation still is the same until we solve for that standard error. So the last step in solving for the standard error is to then take the square root of that value. So the square root of 0.001 is 0.010. So that's our last step there in solving for the standard error. Now we have our formula. This is our formula here that we're going to use to create our confidence interval. Before we actually create the confidence interval, we first have to do our multiplication, following with our order of operations. So 2.58 times 0.010. That gives us a value of 0.0258. So now we're at the final step in which we can create our confidence interval. So we would need to get the lower end, I'll put L for lower, to get the lower end of the confidence interval, we are going to use the subtraction. So 0.887 minus 0.0258 gives us the lower end of our confidence interval. To get the upper end of our confidence interval, we'll do the addition. So 0.887 plus 0.0258. Okay? So 0.887 minus 0.0258 is the lower end of the confidence interval, which is 0.8612. The upper end of that confidence interval is the addition, 0.887 plus 0.0258. That gets us a value of 0.9128. So that's the upper end of the confidence interval. So just like before, instead of us interpreting this as a 95% confidence interval, this is a 99% confidence interval. So we are 99% confident that the true proportion of adults who support expanding solar power is somewhere between this range of proportions that we came up with. So interpreting this has been changed to a percent. So 86.12% rounds to 86.1%. and then 91.28% rounds to 91.3%. So that's why that's showing with rounding. So even though our sample showed us that within our sample, 88.7% of adults had supported the expanding of solar power, that we're 99% confident that the true, real population parameter, the true proportion or the true percentage of adults who support it, is somewhere between 86.1% and 91.3%. Okay? So that shows us now, we've gone over a couple examples of how to create a 95% confidence interval, and then this is one example of showing how to calculate a 99% confidence interval. So the only thing then that I have left to show is to kind of point out some patterns that confidence intervals produce, okay? So if we think of our normal curve here, and in the center we have mu, and we have 1 standard deviation below, 1 standard deviation above, 2 standard deviations below, 2 standard deviations above, 3 standard deviations below, 3 standard deviations above. And thinking about this, so this is actually, remember, 1.96 standard deviations below, and then 1.96 standard deviations above, right? So 95% of our data is within exactly 1.96 standard deviations below and 1.96 standard deviations above the mean, and then exactly 2.58 standard deviations below the mean and 2.58 standard deviations above the mean is what contains 99% of our data. Okay, so kind of keeping all of that in mind, that when we create and produce confidence intervals, we solve the confidence interval equation for our 95% confidence interval and our 99% confidence interval, that the smaller confidence intervals, so for example, a 95% confidence interval is smaller than a 99% confidence interval, right? If you created an 80% confidence interval, that is smaller than a 95% confidence interval. So smaller confidence intervals produce narrower range of values, okay? So I did not show you how to create a 90% confidence interval, but for that solar energy example, that if we were to create a 95 or a 90% confidence interval, that interval is actually 87.1 to 90.3. And then as I just showed you on the previous slides, that the 95% confidence interval in that solar energy example ended up being 86.7 to 90.7. And then the very last slide I just showed you was the 99% confidence interval. So that confidence interval was 86.1 to 91.3. So if we think about that, you know, if we think about our range of values, that ultimately, so we'll put mu in the center. We're thinking about this as our normal curve, right? I'm just not drawing the curve above it. But if we have 87, and I'm going to write all of these out, so say 87.1, and then we have 86.7, and then 86.1, and then we have 90.3, 90.7, and then 91.3, right? So imagine these values are drawn at the bottom here. And so we can kind of think about this as with 95% of our observations falling here between these two values. And then 99% of our observations falling between those two values, that it makes sense that the range that the 99% confidence interval produces is wider, it's bigger than the range that the smaller confidence interval produces. Okay? So that is just a pattern that I wanted to show you to give you a little bit more understanding of confidence intervals and kind of how all of these things connect. So that concludes the end of Section 5, Part A, which is creating a confidence interval for a proportion. So if you have any questions, please let me know. This all corresponds with our homework for the weekend, which I believe is homework 10. Let me just double check. Yes. Nope. Yes. So the end of this week, we have homework 10 that's due. So homework 10 is what you'll be calculating confidence intervals on. So you have creating 95% confidence intervals, for instance, that you would, in a 95%, you would be reporting the lower end of the confidence interval in one answer, and then the question will ask about the upper end of the confidence interval in another answer. So just be sure that as you're creating, or as you're completing the homework, to pay attention to which, if it's asking for the lower end of the confidence interval or the upper end of the confidence interval, and then also just make sure you're paying attention to whether it's asking for the percent or the proportion, right? So in this case, this is showing you the percentage in this confidence interval, but if it was for the proportion, remember, we'd leave it in its proportion format. Okay, so just pay attention to exactly what it's asking you, but if you have any questions on that, please do not hesitate to reach out to me.